What is a ratio? A ratio is a way of describing a relationship between two numbers. In particular, it describes a relationship where we have some quantity of one thing for every so many of another thing. That seems really weird and abstract. Let me show you an example. Suppose I told you that at a party there were 2 pizzas for every 5 guests. That tells you something about how much pizza every guest got. It tells you about the relationship between how many pizzas there were and how many guests there were, even though it doesn't tell you exactly how many of either one there were. So maybe there were only 2 pizzas and only 5 guests. But maybe there were 4 pizzas, 2 groups of 2, and 10 guests, 2 groups of 5. Or maybe it was a bigger party. Maybe there were 20 pizzas and 50 guests. We don't really know. We know that there were 2 times some number of pizzas and 5 times some number of guests. In this situation, when we want to describe it, we say the ratio of pizzas to guests is 2 to 5, or we can write that with a colon, 2:5. Or the last way we can write that is in fraction notation, 2 for every 5. Notice though, when we write a ratio in fraction notation, it is not a fraction. What do I mean when I say that this ratio is not a fraction? It sure looks like a fraction. This is what I mean. A fraction represents just one number, whereas a ratio represents a relationship between two numbers. With fractions, we can do arithmetic. With ratios, we generally don't do arithmetic. And in particular, we will pretty much never ever add or subtract ratios. They do have something in common though. We can simplify them in essentially the same way. Why is that? Well, in our understanding up here, we could multiply the number of pizzas and the number of guests by the same number freely. We could also get rid of a common factor, just like with fractions. So we will be able to simplify ratios by pretending that they're like fractions. But when we pretend that a ratio is like a fraction, it's important to remember that we're pretending. We can also write ratios relating 3 or 4 or 5 quantities. For example, I could say, in my grandmother's biscuit recipe, the ratio of butter to milk to flour is 1 to 2 to 4. What do I mean by that? That means I could make biscuits with 1 cup of butter, 2 cups of milk, and 4 cups of flour. Or if I wanted to make a whole lot of biscuits, I could also make them with 5 cups of butter. 1 times 5 is 5. 2 times 5 is 10 cups of milk. And 4 times 5 is 20 cups of flour, as long as the ratios stay the same. Let's take a minute to look at how we actually write down a ratio, and in particular, how we describe the ratio that we've written down. Suppose at a certain company there are 3 gigabytes of disk space on the computer network for every 5 employees. Then we can write down the ratio of gigabytes to disk space is 5 to 3, or 5:3, or 5/3. Notice the order in which the words appear in the name of the ratio is the same as the order in which the numbers appear in the 2 horizontal ways of writing the ratio. In fraction notation, the first quantity is in the numerator and the second quantity is in the denominator. So we could write this the other way around. We could write the ratio of gigabytes of disk space to employees. That would be 3 to 5. Or we could write it with the colon, or we could write it in fraction notation. Notice here in the name of the ratio, the quantities are reversed, and so they're reversed in the ratio. Order matters. The ratio 5 to 3 is different than the ratio 3 to 5. In particular, the order must match the order in the name. So I'm going to give you one of these to try. Suppose that at an office party, we ordered 36 cookies for 20 people. Write the ratio of cookies to people in 3 different ways. That is, using the word to, using a colon, and in fraction notation. Pause the video and try this now. All right, we want the ratio of cookies to people. That means cookies will come first and people will come second. That is 36 cookies to 20 people, or 36 colon 20, or 36 over 20.